Hi class, for this video, just so you know, I pre-recorded this without sound because the mic wasn't working. So this is going to be me dubbing my voice over the video that I recorded in class that had no sound. Just so you know, if it's a little delayed or awkward, that's why. So I'm going to go ahead and play the video here. And we're on the warm-up page, and this is basically just sort of going back and thinking back to what we did in Unit 4 when we did transformations of functions. We're going to start exploring quadratics, which are parabolas, more closely in this unit. And to start, let's just sort of warm up here by graphing these three parabolas. The one in red will be shifted right 2. So if you recall from Unit 4, you simply go right 2 on the grid, and then you redraw the parabola using the parent function. Every time it moves over 1, it goes up 1. When it goes over 2 from the vertex, it goes up 4. Going back from the vertex right 3, it goes up 9. So that would be the right side of the parabola. And then the left side is just symmetrical to that, and we have a parabola. Now pause the video and go ahead and graph the other two. There they are. You have x squared minus 4, which is the parent function x squared shifted down 4. And then you have the blue parabola, which is x plus 4 squared plus 1, which would be left 4 and up 1. Next, we're going to see the three forms of a quadratic function, which are general, vertex, and factored. And one of the most common would be the general form, which is y equals ax squared plus bx plus c. It's the one that we've been working with the finite differences method. It's also the one that you may have seen in Algebra 1, where you used something called the quadratic formula. It's a very common way of writing out a parabola. The one thing that we do note with this form is that the c will be the y-intercept, and the a will tell us whether the parabola opens up or down. If a is positive, it opens up. If a is negative, it opens down. It's upside down. Another thing that'll come in handy from the general form will be something called the line of symmetry, which we will be exploring pretty soon in this class. The next form is known as vertex form, and this is the one that we've seen that we used a lot in Unit 4. The x minus h, the h tells us how far it shifts horizontally, and the plus k, the k tells us how far it shifted vertically. We saw this in the warm-up. All three of these parabolas were in what's called vertex form. It tells you where the vertex moved. For example, the blue one was left 4 and up 1. It's called vertex form because the vertex is now at -4, 1. The a, by the way, tells us how much this parabola has been dilated. We'll talk more about that pretty soon when we get down to factored form. Speaking of factored form, here it is. We have a times the quantity x minus r1 times the quantity x minus r2. When a parabola is written in this form, the a is, again, the dilation constant. It tells us how much the parabola has been dilated. We'll talk about that soon. The r1 and the r2 will tell us the roots or x-intercepts of the parabola. See, while a line had only two important features, the slope and y-intercept, parabolas have several. They have something called the line of symmetry. They have a vertex. They have a y-intercept. They may have 2, 1, or 0 x-intercepts, and they also have something called a mirror point. We'll explore all those as the chapter rolls on. For now, I just want to show you that the roots of the parabola are considered r1 and r2. They're another name for the x-intercepts. Okay, in our first example, we're going to take a look at vertex form. It says here that Every quadratic can be considered a transformation of the parent function y equals x squared, which is actually drawn in black on this example. We're going to determine how that black parabola becomes this red parabola. One thing that we know is it shifted right 4 and down 2. So we're going to go ahead and write out vertex form, which is a times x minus h squared plus k. Since it shifted right 4, h will be 4, or the horizontal shifter, and k will be the vertical shift. So in this parabola, since it is shifted right 4 and down 2, we can say that the equation will be a times x minus 4 squared minus 2. The minus 4 for right 4, and the minus 2 for down 2. This will be the first time we talk about a, the dilation constant, in this unit. Now, normally, you want to think about how a parabola behaves. For example, on the normal parabola, as you move from the vertex, right 1, you would go up 1. From the vertex, if you go right 2, you would go up 4, because 2 squared is 4. And if you go right 3, you would go up 9, because 3 squared is 9. In this parabola, they give you 2 key points, 4 comma negative 2 and 7 comma 4. So the horizontal change there is 3, while the vertical change is only 6. So what we're going to think about is, how does that compare to how a parabola normally behaves? Normally it moves over 3 and up 9. This is going over 3 and up 6. So it's not going up as far as it normally does. So that's a clue that this parabola has definitely been dilated. It's actually shorter than it normally is. So to figure out the a, let's come up with a simple formula, a simple ratio. Go ahead and write this down. To figure out a, we're going to set up a simple ratio where we put the actual vertical change over the normal vertical change. So in this parabola, it actually has a height here of 6. So normally has a height of 9. I'm talking about when the horizontal change is 3. Normally it goes up 9. This one only goes up 6. So let's think about that. It only goes up 6/9 as far as it normally does. Therefore, the dilation constant is 6/9 reduced, which is 2/3. So my final answer here for this parabola will be y equals 2/3 times x minus 4 squared minus 2. The 2/3 gives the dilation, the minus 4 gives the right 4, and the minus 2 gives the down 2. That's it. Make sure you watch the next video on what's called factored form.